Hello, everybody. Welcome back to Silverlinings Cloud Data Center Strategies event. I'm Liz Coyne, Managing Editor here at Silverlinings and your host for today. Before we get started with our second session, I just want to thank our event sponsors again, F5, Vultr, Aviatrix, Proximo, and Rakuten Symphony. I also want to remind you of a few housekeeping items. If you're having IT issues, you can refresh your browser. That should fix it. If you have questions, you can post them in the Q&A tab on the left-hand side of the screen. All sessions are being recorded and available on demand. And once again, you can join our conversation on Silverlinings social media channels, Silverlinings linked on LinkedIn and Go Silverlinings on Twitter. We are using hashtags today, hashtag Silverlinings and hashtag Cloud Data. With that, I want to kick off the next session, Intelligence and Speed at the Edge, featuring a keynote from Jishnu Kinwar from Chamberlain Group, and then another keynote from Kevin Cochran at Vultr. And then Kevin will be joining the last panel discussion hosted by Zias Caravala, which will also feature Rakuten Symphony. So with that, I'm going to hand it over to Jishnu for his keynote. Over to you, Jishnu.
Good afternoon. My name is Jishnu Kinwar. I am VP Advanced Products for the Chamberlain Group. Very excited to be here for the Cloud and Data Center Conference. Thanks for being part of this. A little bit of brief on myself. As I said, a VP of Advanced Product for Chamberlain Group. I have end-to-end responsibility of all video products across all Chamberlain's platform. The way we'll go about this is we'll talk a little bit about Chamberlain, what it stands for, what it does, what are some of the products we are working on today, and then we'll go a little bit into the challenges which as a group we face when it comes to cloud and technology and all, some of the solutions which we have thought about and I have implemented now and in the past, and some of the investment which we make today to solve those problems as well. So, who is the Chamberlain Group? You may or may not have heard of us, but as I go through, you would recognize that you may have actually. But it's a group based out of Chicago, has been in Chicago for quite some time. It was owned by the Dutchwas family in Chicago, a very prominent family here. And then in 2021, it got sold to Blackstone. But one of the key things about this group is that we have always invested in technology, looking far into the future. So MyQ is a brand, as we go through this, you would recognize it a lot of places. But something for connected world was thought about in 2011. And then in 2020, we started to use video across all our products as well. Nobody else who does what we do thought about any of this when we started off. We have about 6,000 plus employees worldwide, with major presence in US, a manufacturing plant in Mexico, then presence in Europe and in Australia, New Zealand as well. So what are we about before I get into the products which will make you recognize some of the things which we do? But from a company perspective, we are really about making access simple. So we have a lot of products which are in the domain of access control, and we are on a journey of a transformation from a very hardware-based, very high-quality hardware-based company to a combination of hardware and software and how to deliver the best user experience when it comes to access. We have a large install base. The strategy is to connect it, engage our team, and to transform to an access solution business in next 3 to 5 years. So what are our brands? How people know us? People know us through LiftMaster, Chamberlain, MyQ, Merlin Systems, Grifco. So if you look at a garage door and a garage door opener in your garage, you may or may not have noticed, but it's a good chance that you would see LiftMaster and Chamberlain brand brand there, and that's the motor control which actually lifts the garage door up. That's on the residential side, and we have very similar products on the commercial side as well. So, what are our solutions? Embedded vehicles, residential garage door openers, and multifamily access. So, to think about in your car, there are in most of the cars there are three buttons. The home link button, where you push the button and it opens the garage. That's the technology which we have, which allows you to open a garage door sitting in your car. Another exciting thing which we have done, especially on the automotive side, is recently we worked with one of the largest producers of EVs based out of California. You know who I'm talking about, and we have built a completely software only solution there, which when the car drives into the garage, it opens the garage, and when you drive out, it closes the garage. You don't have to push any button. You don't have to do anything. All that is built into the platform. And as I said, similar to the residential side, we have similar gated community access gates which we build, and then we also provide video and multi-family access solutions in various buildings and multi-tenant operations. So and from hardware and MyQ is the really our brand which kind of brings all of this together. So whether it's residential, automotive, community, and facility, we do build all the hardware. So any gate which is there, any accessory to open a garage door, the motors, we manufacture most of them in house. But what brings everything together is the MyQ app and ecosystem around all of this, which brings together the software. As I said before, in 2011, we created the MyQ brand. We knew it's going to be it's important. Software was going to be important. How it'll come around, exactly how it'll work out in 2011. I'm pretty sure we didn't know, but we knew that software and hardware needs to work together, and that's what we have done the past 10 years or so, and going forward, bring video, which is my domain, into everything which we do. So whether it's a garage door opener or a video keypad, we recently launched a video keypad, which you can use to view a live stream, do a recording, or open a garage, create a pin, all of that with video. Right? Similarly with automotive, community, and facility. But again, our idea is how do you make all of this, the user experience, very simple using software with the brand of MyQ. What's the impact of this? Today we have 6.5 million connected garage door openers. Out of them, 1.5 million are video enabled. We're launching more and more video products, whether it's in the residential business or in the commercial business as well. About 200,000 plus connected vehicles which use our technology. Very engaged user base of 9 million MyQ users, and 75% of them interact with our app on a monthly basis. Highly rated app. Most of it started, as I said, in 2011, all built in house and runs on multiple clouds. And this keeps growing. So with that background on Chamberlain and what we do and what we are about, you can imagine the install base which we have from a garage door perspective, from a video perspective. As we are growing, we have, of course, multiple challenges. So the next part, I'll get into what challenges which we face, what are some of the debates which we have, and some of the solutions which we have come up with. Right? So technology challenges. Really, as a company, we are in multiple clouds. We have, of course, multiple partners and multiple platforms. It has grown over the years. Some of it has been through acquisition. Some of it, or most of it, is actually in house. But with acquisitions comes the platforms, comes different teams, comes different clouds. And of course, partnership is important to us. As a connected world, partnership with car OEMs, partnership with the delivery partners like Amazon and Walmart, and various other partners in the security domain. So we have almost everything we can imagine from a data, from a cloud, from an API perspective. And of course, with that kind of multiple clouds, multiple partners, multiple platforms, you get what we call as a lot of challenges and of course debates within the teams and within the platforms. I'm not trying to name everything, but if you look at it, how do services interact? What kind of security are there in the APIs? What kind of access control do we provide to APIs? Where is the identity managed? That's one of the key areas of how we have built the system around, on how do we have a single entity across all domains and businesses when software connects, right? How do you do log aggregation across clouds? And getting a little bit more tactical on how do we build circuit breakers, backoffs, timeouts? How do we make sure that different teams, which are in different places, in certain cases, different continents, how do we make sure that they're writing and building platforms and APIs to the same standards? Of course, we have all the debates which everybody else has as well. Microservices versus monoliths, we have both. There are things we have done on domain-based design where we've gone way into microservices, and then there are things which are built for scale and which we have, especially when it comes to connected world, we have remained and tend to remain in monoliths. REST-based versus event-driven, VMs versus containers, cloud agnostic versus cloud native. With being in multiple clouds, uh, how much freedom do teams have to go deep into their cloud? Will any day would we ever decide to consolidate? And if we do want to consolidate, do we really want to do completely cloud native in one single cloud or in each cloud? Those are some of the challenges and debates which we face on a daily basis. So next, what I'm going to get into is how do we think about, how do I think about in this role and the role previous to this, on how do we solve this, right? And there are no right or wrong answers. So one of the things which we did, which I have done in the past as well, is come up with certain tenets, certain principles which can drive the teams. You have to give the teams autonomy, but there are certain kind of guardrails which you have to put together, and that's what we have done as a organization, as a company, and what I have done in the past. So some of the tenets are, of course, on technology side. Some of them are on process and people side. A few things which we have done on the technology side, and I look at this as a long journey. Is of course every software which we made, especially in the cloud, has to be in multi-AZ. The APIs have to be behind any cache-based networks, geolocated. Another key point which we have done is when you are designing an API, the producer, that means not the client, but the producer or the server side, you are responsible for protection, not the consumer. You cannot expect the consumer or the clients to behave in a certain manner. Yes, there are certain contracts and they need to meet contracts, but if they're not, the producer is responsible, and that's how we protect ourselves. Circuit breakers. One of the key aspects of any design is circuit breakers and timeouts. But one of the things which I have done and we are moving towards is how do we go towards putting those circuit breakers and those things in the network instead of in code. And Istio is one of the technology which is very near and dear to me, and that's something which for the past 2 or 3 different gigs I have had, Istio has been a big savior. Of course, mutual TLS, single identity provider. That's another big one. Is that it doesn't matter which cloud we are in. It doesn't matter whether the company or the platform was acquired or not. One of the things which we want and we are pushing is single identity. So MyQ as a brand is single. There could be multiple platforms underneath it, but the consumer customers which we deal with has a single identity. And then, of course, standardized on WAF and DDoS provider. Okay. Uh, The other part of this is process and people principles. Some of the big things which we think about is how do we spend on tools, SaaS preferred, or people, not both. We also think about working with startups, which is a big part of what I do is work with startups to gain competitive advantage. So use as many startups as you can. We also pay a lot of attention on people. I firmly believe that everybody's resume should build up every year, and of course, ruthless in prioritization. Last but not the least, investments, of course, in people, tools, API management tools, data analytics, log aggregation, and last but not the least, culture. You need to make sure that your people are taken care of. You need to make sure that we're purpose driven, not agenda driven, and how do we build that is key. Well, that's it from my side. Thank you personally from me and the Chamberlain Group to allow me to present what we are about and what we are doing, and things which we have done here. Thank you.
Thank you so much, Jishnu. That was a great keynote. Now I'm going to hand it over to Kevin Cochran at Vultr for his keynote. Kevin, over to you.
Great. Thank you so much. And everyone, very pleased to be here. I'm Kevin Cochran, and I'm the Chief Marketing Officer here at Vultr. I wanted to first call out a little bit about Vultr. Vultr is the large world number one independent cloud computing platform serving over 1.5 million developers worldwide. Vultr as a platform is designed to be part of your multi-cloud strategy. We provide the full range of cloud compute and offer the global reach with a better cost of performance than the hyperscalers with over 32 data centers worldwide. We specifically offer 32 data centers worldwide so that we can empower every developer everywhere in the world and push cloud compute closer to the edge. There is no more important time to push cloud compute closer to the edge than with the advent of generative AI and a new generation of compute power with NVIDIA GPUs. So just a little bit about the Vultr is we believe that we are at an inflection point in our industry with respect to compute technology. As you can see here, over the past 125 years, we've continued to see the application of Moore's law to digital technology. And what's most important about the past 125 years is the point we are at today, which is a seminal moment in the advent of technology with a generational shift in compute power with the debut of NVIDIA's latest GPU, the H100. With this generational shift in cloud compute technology, what we are seeing is a further generational shift in network architecture, storage architecture, and application architecture as people look to unlock the power of data to apply new machine learning models to deliver new applications closer to the edge to deliver new services and new experiences to their consumers. So the key here is that with this new generation of compute power, what's critical is that we avoid the challenges of under provisioning or over provisioning new GPU technology to developers within our organization and across our extended partner ecosystem. And here at Vultr, what we are pioneering is a new platform, a next generation platform of composable infrastructure to help power ML driven cloud native applications. The key here is to make certain that every developer, anywhere they are in the world, has the ability to rapidly spin up, build, test, and deploy to production new ML powered cloud native applications with on demand provisioning in every region around the globe to meet the performance demands of your consumers. So, to pioneer new initiatives and to take advantage of this new generation of compute technology, it's 100% critical that we enable everyone, wherever they live and work, to be able to experiment, to build, test, and out-innovate their competition. What we call this here at Vultr is the GPU bottleneck. And if you look at where developers live and work, typically the ability to provision at scale local GPU power so you can unlock innovation across your team is very limited. As a result, there's an over provisioning in the data center so that people can actually timeshare in order to advance new initiatives. This entire process across the build, test, and production deployment lifecycle makes it very costly, both in terms of time and resources, to speed to market new ML-powered cloud-native applications. With Vultr, we are pioneering a new composable infrastructure cloud. The whole purpose of this cloud is to accelerate time to innovation and accelerate time to market for all of your new cloud-native applications. This basically means cutting out laborious, time-consuming steps in the overall provisioning process to make certain that every developer, everywhere they live and work, can immediately spin up at low cost an entire environment to basically build and test locally all of their new ML models, and then provision them to the runtime environment where they can elastically scale to meet performance demands in all regions around the globe. Our overall purpose here is to push to the edge as far as possible this next generation of cloud compute technology with all of the supporting network and storage infrastructure for fast data transfers for your big data workloads in order to unlock innovation across all globally distributed teams. Now, because this new generation of compute power also requires an acceleration of new application architectures, we also believe that the importance of provisioning your data science teams with all of the resources that they need to speed ML models to production is critical. So what we here at Vultr are really focused on is bringing that intelligence closer to the edge. And this basically means for your traditional cloud native engineering team, provide single click access to spinning up their DevOps CI/CD pipeline. And with our core cloud compute platform, make certain that every single developer can spin up all the local cloud compute and cloud storage they need to be able to build, deploy to test, and then ultimately provision to any one of our 32 data centers worldwide all of their containerized microservices that can scale on demand via our managed Kubernetes offering. This is a traditional cloud compute technology stack, and this is the nature of cloud compute technology up until this generational shift in GPUs. With the advent of new GPUs and ML-powered cloud-native applications, what becomes increasingly important is the ability to support your data science team so that your data science team can actually, with a single click, spin up their own ML ops CI/CD pipeline, and every developer has immediate access to the latest generation GPU so they can spin up their Jupyter notebook, start testing their models against local data, and then ultimately provision to a test environment where they can do their model training and all of their data engineering and all of their performance engineering. What's also really critical is then when deploying those machine learning models, they too need to be deployed into a specialized container environment, a Kubernetes environment, where that Kubernetes environment is available in all regions around the globe with all of the local data and all of the local processing power, so that every single user that's actually accessing your services and accessing your applications has native performance, best performance in order to get the value that you seek to deliver to them. This is a unique new cloud architecture to support both the cloud native engineering team as well as your data science team to truly unlock the power of new GPUs to provision at scale, close to the edge, all of the computational resources necessary to build, test, and scale in the production environment for the best performance in any location around the globe, all at the lowest possible cost. We here at Vultr do this with one of our partners, Domino Data Labs, who I'm with here today in New York City. Together, it's all about accelerating innovation with integrated machine learning operations, leveraging a machine learning operations platform, Domino Nexus, along with Vultr, so that your developers can be free to experiment and rapidly build and prototype new ML models and coordinate the release of those models with all of your containerized microservices for your cloud native application. This is what we mean with Vultr as being the composable cloud infrastructure for cloud native applications, providing the best global reach and the best cost of performance for any enterprise worldwide. So with this, what we're hoping to do with you all and every single digital startup, digital scale up, or innovation team within enterprise is to help unlock the power of GPUs, democratize access to GPUs, and unleash a wave of innovation with the next generation cloud compute platform to best take advantage of this generational shift in compute technology. So thank you so much for joining me today. I apologize for the advancement of the slides, but I look forward to sharing the slides with you at the conclusion of this session. And hopefully, if there's any questions, please feel free to reach out to me directly on LinkedIn, Kevin Cochran. Thank you so much.
Thank you so much, Kevin. That was a great keynote. And now I'm going to hand it over to Zeus Caravala, who's going to be moderating a panel featuring Rakuten Symphony and Vultr. Over to you, Zeus.
All right, thanks, Liz. I guess, Kevin, you don't really need to introduce yourself since we just got a whole lot about you. But yeah, also joining Kevin and I is Mehran Hadipour. Why don't you just do a quick intro to yourself and tell us what you do and and a little bit about your company.
Thank you so much, Mehran Hadipour. I appreciate the opportunity to be part of the panel. I'm part of a organization in Rakuten called Rakuten Symphony. We basically, Rakuten, as you know, is a large conglomerate with a lot of different businesses. Rakuten Symphony is basically a software provider for our telecom operators that includes a number of lines of business, including network services, software for cloud, and orchestration and automation, and so on. I am part of a division of Rakuten Symphony we call Telco Cloud. So we have a infrastructure and automation platform for deploying complex network-centric applications in the cloud. A pleasure meeting you.
Yeah, pleasure meeting you too. Now, we're here to talk about Edge, right, which is very complementary to cloud. One of the interesting things I find about Edge, though, is it tends to have a bunch of different meanings. In fact, I was having dinner with a CIO friend of mine a couple of months ago, and I asked him what his Edge strategy was, and he says, "I don't know," because every time I talk to a different vendor, there's a different definition of Edge thrown at me. So, Kevin, why don't we start with you? What is the Edge exactly, and why is it important?
Yeah, I think the whole definition of an edge is changing. In fact, it may even be going away. So when you think about the edge traditionally, the advent of it was way back in the early days of the web, where you just wanted to have low-cost machines scattered throughout your POPs so you can cache content and deliver it much more quickly, right? That whole world doesn't really exist anymore. At the end of the day, with new cloud native applications and new application of data science to power those applications, you need to have a lot of raw processing power and local access to data and as many distributed points around the globe as possible. You're not just caching content or providing simple access to basic services. You're doing real computational work to deliver personalized, tailored experiences to your customer. And this becomes even more so with the advent of 5G and the connectivity boom that's going to be coming with 5G all around the globe, especially in emerging markets in places like India and elsewhere. So the real question is the edge is going to fundamentally transform, and what might have been just a low cost, caching, server now has to be upgraded to actually provide kind of the raw performance that you need to deliver your applications and a fantastic experience to your customers. The other thing with the edge is it's a little bit of an odd term in the sense of what is the edge? If you're in India, do you consider yourself in the edge? If you live in South Africa, so do you consider yourself in the edge? What about the edge, is a very kind of North American centric view of the world. And we here at Vulture believe every developer, every organization, it matters. And, if you live in Santiago, you don't consider yourself at the edge at the end of the day. So we believe fully that, cloud compute technology needs to be pervasive across as many points of presence as possible, not just regular cloud compute, but also all of your next generation GPU infrastructure. And what formerly was the edge now becomes the frontier of new innovation.
All right. And how about you, Mehran? I know you've got, you had some in our kind of pre-panel email discussion. I think you had some thoughts on, edge cloud and, some of the important parts of it. So why don't you give us your definition of the edge?
Yeah, that's a good question. I mean, I think edge is one of those words that it kind of depends on the context of when you talk about edge. If you think about the data center, typical data center perspective, and then public cloud, edge would be a third alternative of delivering services, in my view. It talks about infrastructure very close to where the data is created. It is important in use cases that you need to actually do quick analysis of local data, AI applications, computer vision applications, and so on. Or the volume of data is so great, you cannot transfer it all to the primary data center or the cloud. So you deploy satellite infrastructure, you can call it the edge, that hosts these types of applications and deliver intelligence locally, and then the summary of it could be sent to the cloud. So that's kind of a typical definition of the edge. Now, the edge cloud, on the other hand, could mean multiple things. That we have the cloud native model versus cloud ready approach to delivering at the edge. Now, cloud native is a very interesting transition for the edge application use cases, because now you can build a very efficient infrastructure that is remotely managed and deployed zero-touch provisioning fashion, hosting certain applications that require low latency at the edge. On the telco side, edge means a little different, because if you're doing 5G services, we're talking about CUDU workload running on a base station, you can call that an edge, right? You have a small x86 footprint on the antenna that is radiating a signal, and then you have a few computers that does the CU workload. So whether you're talking about telco edge or enterprise edge, the infrastructure might be different, but the concept of having a distributed infrastructure that is managed remotely and processes information is somewhat the definition of what I call the edge.
Yeah, it seems like it's everything from your everything between your private data center and your public cloud can be called edge, right? Telco edge, enterprise edge. And I think that's where some of the confusion comes from, but they all have different use cases. Oh, and by the way, if you're in the audience, I do want to invite everybody to ask questions. There is a Q&A widget in there, and we'll take them as we get them. Both these speakers said they were the smartest guys in edge, so there's nothing they can't answer. So feel free to ask. Now, Kevin, I'll go back to you. When and you touched on a little bit with the relationship of edge to cloud and things like that. Is it like, do you see over time the edge being complementary to cloud? Will it replace some clouds? You know, is it likely you'll purchase your edge services from your cloud provider? And so what's that relationship like between edge and cloud?
Yeah, no, I think the cloud is indispensable to the edge and where it is going. If you really think about the edge really is pushing out as close to the edge as possible. I mean, the new frontier is like literally like your home. And with all of the IoT devices that people are placing in their home, that to me is also kind of the local computing power that's actually delivering performance and services to everyday consumers. And what those all need to be connected to is, a cloud platform on the back end that is optimizing performance, optimizing inference models using locally accessible data in order to power kind of that experience that you're having in your home, in your car, in your work, in your remote workplace, etc. So I do think that the cloud is absolutely indispensable to it, particularly now that we're in a new world where your applications are all data powered. So being data powered means every one of your edge services, every single application workload needs to be connected to something, because that local data that's being captured needs to be able to funnel back into all of your centralized data storages so that new machine learning models can be built, can be trained, and then those trained models, as well as the data, can then be reprovisioned back to the edge to support all of your inference and each of your kind of applications that are delivering a service to your consumer. I think in prior generations of compute infrastructure, where you had a lot of cloud-ready applications that you could deploy to low-cost hardware that might be close to where consumers lived and work, and there didn't have to be any sort of tethering to any sort of back-end systems for purposes of data management, data engineering, and machine learning model development. That was a different world. But I think that the world today we live in does require that the edge be closely connected to the cloud. And honestly, the edge itself, to the best extent possible, should be deployed on cloud infrastructure so you can support the full application lifecycle management as well as on-demand provisioning of new services.
Yeah, Mehran, do you agree with that, or do you have anything to add to that?
I have a slightly different tint to that. I think I mostly agree to the concept that was mentioned. To me, the reason for the edge has always been that the fact that you need to have processing power where the requirement of data is. So data is collected at the edge and needs to be analyzed at the edge. Let's think about like a digital twin, a computer vision application, or things like that generates gobs of data. You need to make decisions in a split second about what to do, a plant operation, for example, or stop the line, or do things of that nature. A cloud, if you think about the traditional definition of cloud, would never extend all the way to the far edge, right? It would be very expensive to build a cloud for everybody, right? So you're going to have infrastructure that is in the mine, in factory, in the shipyard, in a store, right, that is processing data, right? These data processing elements that are remote, the role I see for the cloud of this is that you have very little IT resources at that location. The infrastructure is not that very large. You have important data to protect. So all the orchestration and automation of that infrastructure at the edge needs to be centralized. And the best place to do that is at the edge, at the cloud. So I see cloud being the management layer of the edge nodes.
Yeah.
Automation and orchestration platforms will run the cloud, and they would do zero-touch provisioning, lifecycle operations, scaling and healing, all the things that the edge nodes need remotely. but the processing of data would really still reside at the edge, and they coexist together and they depend on each other. Whether you're using private cloud or public cloud doesn't really matter. I think even the cloud providers, like say Google, for example, is looking at those kinds of workloads with Anthos bare metal to try to extend the control of cloud to the edge deployed resources, right? So I think edge would be the new frontier for fighting where the infrastructure should be, but who's going to own it and where you're going to buy it. But it is something that it is unique in the sense that even the type of data at the edge could be unique. You could be depending on intelligent devices or barcodes or quality control cameras or things that they share. So it is something that is very specialized and use case dependent. So I imagine that to still survive as an independent go-to-market with some of these providers.
Yeah, and I actually completely agree with. Oh, sorry. I was just going to say I actually completely agree with everything that I just heard, and I think you said it so much more eloquently than I. At the end of the day, every factory floor, every home, every car is going to become a new form of a digital workplace with all of the local data that's being collected, that needs to be, quickly analyzed and then ultimately acted upon. And all of that needs to obviously live locally on that factory floor, in that home, in that remote work site, be it a construction site or a mining facility or so on and so forth. And I think to your point, it has to be connected to something, which is that management layer, which is the cloud, which is rapidly provisioning new resources to those remote devices and those remote environments, and then obviously collecting the critical data that's needed to provide better business insights, to funnel more local knowledge into kind of a global data set that can be analyzed and used by your data science teams to build and train new models that can be deployed out and pushed out to the edge. So completely agree with everything that you just said. And I think you just said it so eloquently. So thank you.
Now, you've mentioned connectivity a couple times. Do you believe at the edge, Kevin, the connectivity needs to be always on, or can you have intermittent connectivity?
I think you can. Well, the answer is both. So in the ideal case, you want to have obviously persistent connectivity, but you can never bet on that because there's always going to be discontinuous events that basically knock out access to any sort of centralized cloud infrastructure. And your services at the edge need to be fully autonomous and be able to continually run. I live in the state of Florida. So, we have a hurricane that can wipe out an entire city. I was in Mexico Beach just this weekend on the Memorial Day, which was a city that was completely wiped out by Hurricane Michael. So any sort of local response infrastructure always needs to be able to work autonomously, even in the event of a disaster, so that citizens can be served, so that the consumers can be served, so on and so forth. But yes, ideally, you will have some sort of persistence. And I think this is the promise of 5G and kind of the connectivity revolution that, telecom providers are now advancing, is we do have the promise and the hope in the future of having, super high bandwidth, persistent connectivity for all remote devices to power next generation workplaces, next generation homes, next generation vehicles, and so on and so forth. But just because we have the supporting infrastructure for that level of connectivity now, doesn't mean you should ever be dependent upon it, because things do happen, and your workloads still need to be able to operate autonomously and work.
So let's talk use cases here, right? Because whenever I talk to the telcos or cloud providers about edge, I get a lot of use cases that we're very well aware of: oil and gas, field service, things like that, where edge has been popular for years and years. With the rise of 5G and AI and things like that, what are some of the new use cases for edge that we'll see, become the low-hanging fruit for more businesses, right? Because as long as it remains those traditional use cases, I don't know. To me, that's not that exciting. So, Ron, why don't we start with you? What do you see as some of the newer use cases for Edge that we didn't have in previous generations?
Great question. I think going back to when you ask someone the use case at the edge, it depends on their point of view. Obviously, the operators wanting to take advantage of the low latency 5G and high throughput 5G networks want to deliver additional services at the edge, right? If you're providing high-speed connectivity to a larger audience, there are a number of use cases that open up. For example, CDN, content distribution, MEC use cases, event, AVVR capability on local events, sporting events, airports, enhanced connectivity to consumers watching a show or so on. These are things that telco guys are focused on. And there are use cases that they feel would generate incremental revenue because just 5G itself is not going to give them any additional revenue. Yeah. Right? You have to build new use cases. Outside of that, I think this whole 5G revolution would generate ability to support the kind of very interesting new use cases that wasn't there before. For example, a lot of these smart city use cases, active traffic management, for example, incident management, transportation scheduling, automation. Imagine that you're on a bus stand and everybody that's sitting in a bus stand, and you can dynamically reroute the bus depending on where people are waiting. Why you go places that nobody's looking to get on a bus. So there's a number of things that's going to open up that changes the way we consume, generate, and manage data at the edge. And the fact that 5G allows you to kind of extend the connectivity at a high speed to a large number of locations would open up a number of additional use cases. Some of the traditional applications, there's also things that is coming up. For example, digital twin applications. Having somebody who's repairing a turbine look at the turbine image on his iPad while he's repairing it. So a number of these kinds of things could also be feasible now, which wasn't feasible before, because you can actually guide someone to do something very specific with a very high computer vision kind of model and so on. So I see the use cases, if anything, grow. The question really becomes on who is going to have the initiative to have a solution perspective and develop that as a service, because the enterprise customers they're not container savvy, they're not connectivity savvy, they want to buy it as a service. So whoever takes the lead on providing these as a service for the community would be successful in this market, I think.
Yeah, Kevin, do you have any other use cases you want to share?
Yeah, I mean, just if you think historically about the edge, if you had a limited number of locations that were performing some very complex job that a very high cost of operation and involved a lot of fixed capital, typically you would provision infrastructure to support local compute capacity in order to best optimize those operations, right? And I think what's changing now is in non-traditional environments where you don't have a lot of fixed capital, where you don't have a lot of costly jobs, where you don't have high cost of operation, just everyday life, places that you go in your everyday life, all of those locations now have the power to be able to collect data, process data, and deliver you a better citizen or consumer experience. So I think the whole revolution of the edge is going to change pretty dramatically how we live and work in our everyday life. Now, I always like to think of this in kind of like three realms. So first of all, there's the consumer realm, there's the public realm, and then there is the non-digitized world, which is now going to be able to be rapidly digitized. So let's talk about use cases in each of those three. At the end of the day, every one of us is just looking to get from point A to point B. We want to accomplish a goal, and then we want to get to that goal as expeditiously as possible, right? And that means things like if I'm going into the grocery store, why cannot, when I'm in the grocery store and picking out things off of a shelf, why can't I be immediately notified of all of the other items that might complement what I'm picking up in order to help me create the dinner that I'm looking to create, right? That's a form of edge computing where the entire grocery store becomes one big digital self that's actually tracking what I'm actually putting in my basket and making sure that it's optimized against the goal that I'm seeking to achieve, which is to create a wonderful dinner this evening, right? That is a good example of where we can start leveraging kind of the edge. Similarly, if I'm going into any sort of retail store, same thing occurs. If I'm actually looking to go out for the evening and I'm going to look to get a new pair of shoes, that entire retail store can be completely optimized to help me with a better in-store experience in order to not only get a pair of shoes, but get an entire new outfit so I can accomplish my goal of having a fantastic evening. So there's going to be many applications in our daily life where we're going to be, as consumers, able to live a happier, healthier, more productive life because every single restaurant we go into, every single store we go into, with the advent of new, generative AI services and new low-cost cloud compute, every single establishment should be able to retrofit itself to locally collect and process data and help everyday consumers achieve the goal that they're seeking to achieve. Now, that's in the consumer world. In the public world, I think that was a very good example that we just heard about dynamically rerouting, bus lines based on the people who have actually entered in the bus and kept figuring out that optimal path. If you look at the public sector in general, the public sector has not made great use of data to drive the tailored delivery of digital services, and in turn to have those digital services support some sort of public mission like transportation. So I think what you're also going to start seeing is within local, state, and federal governments around the world, a wholesale rethinking of digital architecture so that they can start supporting a better citizen experience. Citizens themselves, we want to accomplish a goal. We simply want to get from point A to point B. And if that means having better intelligence on local bus lines so that they have the most optimal route to get me around traffic, to get me to my destination quicker, that's a public good, that's a public service that delivers a better citizen experience. Now, I think in the other part of this is there are still large swatches of the world that are still not fully digitized. I recently just came back from India.
Right?
Yeah, they're just getting connected. I mean, India just became the most populous nation in the world, and we tend to think of India as being extremely advanced technologically because of just the sheer range of developers and innovation that comes out of India every single day that's powering all of our technology that we use. But at the end of the day, there's still large swatches of India that are just now getting connected, small to medium businesses that haven't fully digitized. And so there's a whole new range of digital services and digitization that is now only possible with the advent of 5G. And this is one of our exciting missions here at Vulture, which is how do we support across all of Latin America, across the entire Indian subcontinent, across Southeast Asia, across Africa. How do we support kind of the lighting up of new digital ecosystems and new digital services in places that formerly just did not have great connectivity? That's the new edge. That's the new frontier, I believe.
Yeah. And, I think to me, video becomes one of the big use cases as well. In fact, that was interesting watching the keynote because I actually just bought one of those garage door openers with a camera in the bottom. And whenever nobody opens the door, it does a bunch of analytics on things like that, tells if they're, it tries to interpret what they're doing. So that's kind of interesting. We did have a question coming from the audience, and it's an interesting question because I think what we've kind of distilled down to, there are a couple of different kinds of edge, an enterprise edge and a telco edge, right? And I think even within that, you could probably get more granular than that. But when it comes to providing services of enterprise versus telco edge. What are some of the challenges that are unique to each of those environments, or is there really no difference between the two? And do you want to take that?
Maybe I can get started with the answer. I think it's a very good question, actually, right? So what exactly is the difference, and what are the challenges for each one? I do think that there are significant differences in terms of both the technology requirements and also the scale and complexity of what is being delivered for each case. There are common areas between them, but if you think about a telco wanting to do services at the edge, you're talking about, for example, delivering of 5G services, right? We're talking about hundreds and thousands of base stations that have to be deployed. The scale is a lot bigger, obviously, in the telco side. Then within each base station, you have to have capabilities to provide 5G radio connections, which means that you need now a platform that has high performance networking, including network acceleration, SRIOV DPDK support, Maltas to have multiple connections, a small footprint, so you have to have a Kubernetes distribution that can run on a single box or maybe a 2 or 3 box, because you cannot afford a data center at every base station, right? And on top of that, everything has to be as much automated and zero-touch provisioned as possible for the telco use case. We are supporting cloud to a number of these 5G deployment use cases, including in Japan. We have about 5,000 edge data centers deployed with our cloud platform. You can have a lot of infrastructure at that edge. So the Kubernetes distribution we deliver, it runs on a single core. So you have to have that kind of capability. So it's very different deployment for the telco use cases as opposed to enterprise. On the other side of the coin, the enterprise use cases, usually you have larger infrastructure. You do analytics and data management at the edge. And what's important is data services. Things like protecting that data, native encryption, snapshot and cloning, backup and recovery. That doesn't really, is not a factor for the telco use case because everything is live real time. Although the telco network functions are persistent, there's not a lot of data that is being stored at the edge. All the enterprise use cases store data, manage data, replicate data, protect data at the edge. And you need to analyze data. Things like GPU becomes important for the enterprise use cases. But nobody's going to put GPUs in the base stations. Right. Nobody can afford it. So the use cases and infrastructure varies quite a bit between the enterprise.
Well, that's not totally true. And maybe Kevin, you can pick up from there too, talking about the requirements, for edge, and specifically where you might not deploy GPUs. I don't think you can just put any old off-the-shelf server out there either. Like these things will likely be loaded up with SmartNICs and DPUs and things like that have GPUs in them, correct? Yeah, and so
what are some network acceleration?
Yeah,
correct. I always view the two as very complementary, and this is also the reason why we here at Vultr are the enterprise cloud compute platform for Airtel connected to their 5G solutions, right? So if you are looking at, your 5G services, at the end of the day, they're going to be critical for experience delivery. And if you're looking at a new world where we're moving to more serverless functions, which we are and we should be doing, basic serverless functions for experience delivery, personalization should be pushed as far out to the edge as possible. And that includes all the way out to your base station. So if you believe that your base stations are kind of that frontier, that edge, I would suggest that certain sets of serverless functions are what will execute there in order to tailor and optimize the delivery of the experience to the end user. Now, that's basic personalization that you would be doing through those serverless functions. Very, very simple stuff. Anything that's computationally expensive, of course, would need to happen at a locally available cloud compute location. And those cloud compute locations, very critically, are going to be a mix of traditional CPUs as well as GPUs. And it's going to be each running specialized Kubernetes containers, one Kubernetes container for your containerized microservices to power your application, and then another Kubernetes container, which is managing the scaling of your machine learning models as you're doing all of your local inference based on local data centers that you're accruing from all of your local base stations. The computational resources that are required to really do, kind of the next generation of consumer services and public services, both for enterprise consumers or small to medium businesses, will require optimized cloud compute infrastructure in order to make sense of all of the data that you're collecting and to uncover what it is that the consumer or the citizens trying to accomplish, and how best can you provision the right resources at the right time. So all of that needs to be closely connected to your base stations. Your base stations can do the basic optimization of experience delivery, but all of the raw horsepower does need to be still behind them in the cloud and as close to the edge as possible. So you're talking about every single major population center should have a cloud compute location that has a full range of compute resources necessary to power all your 5G base stations.
I think what you're talking about is the vision of yeah, I think what you're talking about is the vision of of distributed computing, where my edges, private clouds, and public clouds all kind of work together, right? And then
Correct.
I might I might look at some data at the edge, but I'll send that data back to the cloud for my centralized cloud for a different type of analytics. Now, the challenge with that is, frankly, we can't get two cloud providers to work together, right? And how does that manifest itself? If the vision is this world where we just have this big compute fabric and we can move,
Right.
How does that manifest itself?
Right. Maybe I can jump in there. I love the word that you just used, compute fabric, because that should be the vision that we all seek to drive towards. And at the end of the day, workload should be, and data should be completely portable across any infrastructure, across any cloud. Here at Vultr, we're like the only independent cloud that's a member of the MACH Alliance, which stands for Microservices, API First, Cloud Native, and Headless, which is an industry-wide consortium of cloud native technologies that's all about application portability, so that you don't have any lock-in to any one vendor. Lock-in is a bad thing. Lock-in is ultimately what stifles innovation in the long run. And I think the challenge that we've seen in the cloud compute industry, with big hyperscalers, is they absolutely seek to lock you in, and that has got to stop. So at the end of the day, everything should be complete. Every service, every infrastructure service should be completely autonomous, completely orchestratable, whether it's from cloud provider A or cloud provider B. This is a notion that we here in Vultr are pioneering, called composable infrastructure, which the whole definition of composable infrastructure means it is completely autonomous, independently discoverable, and easily orchestratable. So it's plug and play with any other infrastructure service that seeks to be, follow the MACH principles as well. So has to be, super composable, no lock-in. That can never happen. It's bad for the industry. It's bad for enterprises. It's bad for the consumer. It's bad for all of us.
So how about from a Rakuten perspective, Mehran? Is what Kevin talked about possible? Here, personally, from my perspective, you're talking to an old Unix and C developer that was told, if I write something on C for Solaris, it'll work on HPUX and it'll work. But that never was true, right?
That never worked. That never happened.
Right. There was always different variants of it. Can we actually get to a world, Mehran, where we do have cloud independent composable infrastructure where and by the way, Kevin, I agree that's what's needed because openness and interoperability has always been proven to drive utilization up. Sometimes the hyperscalers don't really see it that way. So, Mehran, I'd like to get your thoughts on that.
Yeah, it's a good question. I think I would say we are a lot closer to this nirvana as we have ever been. So let me just start there. I think the way we get there is to have a cloud native infrastructure, which is infrastructure independent. For example, let's say imagine that you have a Kubernetes-based distribution that could run on-prem or any cloud. And second thing you need is an application delivery model that can support both containerized workload and non-containerized workload. So we've built our cloud to support running both VNFs and CNFs, containerized on a common platform. So you don't have to rationalize your application before you run it. Then we also did, instead of writing a Helm chart and programming that is dependent on the infrastructure you're deploying on, and every time you have to migrate or worry about what is the underlying cloud that you're going to run on, we build an app store-like experience that is GUI driven, and you can then create a bunch of applications that can run on the cloud no matter where the underlying infrastructure is. Whether you're running at the far edge, or running on a public cloud, or you're running on a private cloud in the data center. So you build it once, if you will, and then underneath infrastructure is completely stay independent. And it's really based on Kubernetes and the fact that it kind of homogenizes how a lot of these lifecycle operations are done post-deployment. We added on top of that the level of orchestration that automates the onboarding. Now you have a zero-touch provision model that you can push applications to the edge, and no matter what is deployed at the edge, Kubernetes and the orchestration layer takes care of provisioning automation, scaling and healing automation, observability, and so on. So once you have that kind of level of automation and management, then you're very close to that issue. Okay, I'm going to create this infrastructure once. I can go from one vendor of cloud to another. I can change my infrastructure. I can run it at the edge. I can bring it to the cloud, and so on.
Yeah, because I've heard many CIOs describe the hyperscalers as Hotel California, right, where you can't, you can check out, can't ever leave. So we got 5 minutes left. I'm going to ask each of you to put yourself in the audience's shoes. If they're interested in edge computing, what are some key questions that they should be asking to make sure they're not going to wind up in another lock-in situation, or at least, to make sure that they have some options. So Kevin, you get try and keep the answer short because we only got 5 minutes. I want to get to both of you. So you go first.
So, I mean, I think that there's kind of 3 key questions, which is how portable is your data and how portable is your workloads? Are all resources independently orchestratable via something like a Terraform template or not? This becomes really, really critical because if you do look at the hyperscalers, it is Hotel California, both at the compute layer in terms of the application services provided and the dependencies between them, which is complete no-no, by the way. If you want portability, you cannot have dependencies. That's a bad thing. Not only at the compute layer, but also at the data layer. So number one, focus on that core principle of portability and really inspect and analyze that, okay? I think the second thing is you need to take a look at what is a roadmap for standing up compute infrastructure as close to where people live and work as possible. So, where do your consumers live? Like, where is the local data center? And what is the roadmap for continually pushing the edge in terms of that data center location so it gets ever closer to your 5G towers, ever closer to your consumer? And the third thing I think that's critical to look at is just the completeness of the compute stack. Does the compute stack support a full range of CPU and GPU options? And to the prior point, all of the supporting Kubernetes infrastructure for both GPU, which is different, by the way, as well as for CPUs, so that you can independently scale your workloads across clouds and across locations.
All right, and Mehran, you get the last word here.
Sure, thank you. Well, let me offer three principles based on the very interesting question you raised. One is that you need to stay in cloud native. You need to pick a cloud native infrastructure platform that runs not only on-prem, but on any other cloud. So it can be mobile. You can run that platform on AWS, Azure, on your prem, or on the edge. The second principle, I think, is that to worry about your data. Data has gravity. It's easy to move applications, but it's not so easy to move data, right? So you need an infrastructure platform that has data services that are application aware. So, for example, you're building a distributed edge infrastructure with data created in each location. You should be able to take a clone or a snapshot of that application with the consistent data and move it to another node or move it to the cloud. So think about how data is created, how it's protected, and how it's managed. And the last thing is to put the right application in the right place. Don't force fit. If, for example, if you don't need the applications to run on the edge, you're better off centralizing them and running on your private cloud or public cloud, right? Applications should be placed at the edge that require low latency, and it's important for them to be close to the edge, right? Edge edge deployment should be targeted to the use cases that requires it, is my third suggestion.
All right, thanks. And we got 30 seconds left, so that's awesome. And I do think if you're watching this, it is important to fully embrace what both speakers have said. Openness, interoperability, portability, that's only going to benefit you. And frankly, when you're dealing with the hyperscalers, insist on that, because the more that you're willing to accept, the status quo, the more locked in you're going to get. And I think that that's gotten companies in situations in the past where they can't move their workloads even when they want to, without great expense for migration, right? So I think the only way that changes if you in the audience insist on that. So on behalf of Mehran and Kevin, thank you very much for your time. And I think I'm passing it back to Elizabeth Coyne, aren't I?
Thank you so much to all of our panelists. And I'd like to once again thank our sponsors from today's event, F5, Vultr, Aviatrix, Proximo, and Rakuten Symphony. As a reminder, Silverlinings is on social media. You can find us on LinkedIn at Silverlinings and on Twitter at GoSilverlinings. For today's event, you can use hashtag Silverlinings and hashtag Cloud Data. Also, we have a post-event survey. We'd love to hear from you. You can keep a lookout for that survey in your email, and we appreciate any comments or suggestions for our future events. Speaking of those future events, we have 3 lined up for you. Cloud Native 5G Summit is scheduled for June 27th to the 28th. Cloud Observability Summit is scheduled for August 10th. And Cloud Core Strategy Summit is scheduled from September 18th to the 19th. We look forward to seeing you at one of our upcoming events. And with that, I'm signing out here from Silverlinings, and I look forward to seeing you at the Cloud Native 5G Summit in June.